So today we're going to be talking about 11.4, three-dimensional figures. Okay? And kind of the warm-up I gave you on the way in, the start by thinking there, kind of addresses the essential question of what's the relationship between the number of vertices, edges, and faces of a polyhedron. Now, polyhedron we'll define in a while. However, you have some polyhedrons right here, okay, on your start by thinking. All right, so working with a partner, I want you to go through, answer those questions, and then after you finish that, you can go through and answer the 3 on the bottom there. Okay? Very good. We'll give you guys about 5 minutes or so to work through that there. All right. Well, it appears as though many of you on the top got the same thing that I got. They all equal 2. If we apply the formula, or that expression there, f, or the number of faces plus the vertices minus the edges, you always come up with an answer of 2. That's kind of cool. It's a nice little relationship that you have when you have polyhedron. Polyhedron are bounded by polygons, so we kind of define polyhedron up here also, right? So anytime you have a bunch of polygons that are bounded together with edges, those polygons become faces, okay, and they form vertices. So the number of vertices and the number of faces and the number of edges, if you put them in this relationship, f plus v minus c, you always get 2. That's pretty cool. All right. Well, on the bottom here, number 1 is a polygon. Number 2 is not because it doesn't have edges. Okay, there aren't any edges. They're rounded there. Number 3 is not because it's a 3-dimensional figure, and a polygon is actually a 2-dimensional figure. So number 3 is made up of polygons, right? It's a bunch of polygons bounded together, okay, which makes a polyhedron, but it's not a polygon. Okay. Any questions on that? Just a brief review there, and hopefully an aha here. Okay, so we are going to take out your student journals, open them up to page 329. There's a little more of that exploration if you wanted to explore a little more on the vertices, edges, faces piece. Definitely don't have to, but you can. Did you break your calculator?
I mean, I break calculators.
Maybe it's alien writing. Maybe they're trying to communicate. You might be the person they chose.
You're the chosen one.
That's awesome. Well done.
Maybe my calculator needs new batteries.
It doesn't have batteries. It's rechargeable.
Oh. Well, maybe
This needs batteries.
Right.
Well, maybe there's still batteries, but you have to charge the batteries.
Okay.
Sometimes the batteries
We're having our alien conversation up here, so we should probably move on.
You're the chosen one.
Okay. So page 329. Like I said, you can go through it if you want on your own, but we're going to skip that one today. And we're going to move on to page 330, which, once again, it gives you a little background about the faces, edges, and vertices. Talks about Euler. And Euler is this, amazing mathematician. Did we talk about, by the way, Doug Baldwin yesterday? Did you guys, how many watched the Seahawks? Did you guys hear what Doug Baldwin wants to be when he grows up?
No.
Dude, he said it. They said it on the, they said that when Doug Baldwin grows up, well, that's not how they put it, but when he finishes that thing he's doing with the NFL, when he finishes being a receiver, he wants to be a high school math teacher.
I would like him as my math teacher.
Isn't that awesome? My thought is really what I could do is him and I could just switch. We could job share.
No.
I'd go out there and be a receiver. You could take over in here for a while.
That would be amazing.
Oh, I could go over and get crushed
My mom would come to school
for
every
a
day.
lot of money.
She would stop
Huh?
by my math class every day.
Yeah, I probably would want to be
What
on
are you
defense. It's
doing?
true.
I really
All right.
I'm out of your grade.
Or maybe I could just send him a jersey with my name on it.
I
McCoy,
think that
yeah.
we should talk
Since
about
I have
that
his
in
dream
the
job.
future.
What's up?
Look at your pyramid. Hi, teacher. I'm a high schooler.
Yeah, he did. I don't know, but you did. All right, sorry, we got sidetracked. Anyway, if you want to explore more here, there you go. Page 331 is where we're going to start. Everyone take a look at 331.
My mom.
Right now, you guys need a textbook. I need you to go through and define these terms on page 331. So grab a textbook. Use pictures, words, anything that helps out there. Remember, when you guys go through definitions, you want to put definitions that make sense to you. So put them in your own words, right? Make it so that it makes sense to you. And a lot of time, you guys can find this section or stuff in section 11.4. I see a lot of us looking at the glossary, which you could do, but it's in context in 11.4. Okay, so a lot of times you see pictures and examples that you wouldn't see in the glossary.
Well, I mean,
I'm flabbergasted. Okay.
well, Haley doesn't like pizza,
What?
so
We already went over this.
All right.
just trying to back myself
Here we
up.
go.
Say something.
Polyhedron, volunteer.
Um,
Yes, Grace.
A solid that is bound by polygons, so it's like a solid made out of polygons.
Good. It's a solid made out of polygons. Very good. And we talked about that a bit right here. You guys remember in our warm-up. Okay. And faces, edges, and vertices, or vertex, well, those are defined right here really well for you. You got your edge, you have a face, the front of or a side of a shape, and then a vertex. Each of those little points. Okay. A cross section. What's a cross section? Kino?
The intersection of the plane and
Good. The intersection of a plane and a solid. Okay, that is a cross section. So these are, now I don't actually want to put all those up there, but let me give you a picture of a cross section. This is off of your assignment today. This is a cross section where you have a plane intersecting a solid. In this case, you have this plane intersecting a rectangular pyramid there. Okay? All right. Very good. Okay. Solid of revolution. Yeah, Carson. Yeah, 3D figure rotate or formed by rotating a 2D figure around an axis. So if you take an axis and you rotate it, in fact, the best way to do this, and I should have got these out for you, is to take like a note card and put it on your pencil and rotate it around. You ever take a note card? In fact, let me grab one real quick. Here's my note card rotating around it. So that's my amazing, actually this Vogel put together, so I can't take credit for this amazing construction. But if you take a note card and rotate it around a pencil, and you keep swinging it around, now it's easier if I can actually do this from the bottom. Okay, but if you swing that around, what shape does it sweep out? Sweeps out a circle, right? It's not really a circle. Three-dimensionally, what would it be? Cylinder. It'd be like a cup of some sort, right? It'd sweep out that cup. Okay? So in two-dimensional, yeah, dude, CW. Two-dimensional, it make a circle. In three-dimensional, it makes a cup. Okay? Or a cylinder, if you think of it that way. That's a revolution, solid of revolution. And then the axis of revolution is what you're actually rotating upon. So that'd be your pencil in this case. Okay? All right. Pretty neato, man. Yeah. Okay. Any questions? All right. Page 332. Let's take a look at it. Page 332. There are some different polyhedron here, and I just want to make sure we emphasize a few things on this. First, this prism has a special name, and it's named upon its base. This is a rectangular prism. So we're going to be more specific here. That is a rectangular prism. So this is on page 332. This pyramid, this is a rectangular pyramid. Now, what makes this a rectangular pyramid and this a rectangular prism? Go ahead and tell your neighbor. What makes them that?
All ones are rectangular.
What makes it a rectangular prism and makes it a rectangular pyramid? All right. What do you think, Emily? Oh, what's up? No. No. That's just a cone. By definition, it has a circle as a base. Good question, though. Okay, volunteer. What makes them rectangular pyramids and prisms? Someone that, Maggie, what do you got? Good. Its base is a rectangle. Now, some of you may argue, well, the base here is actually a square, where a square is a rectangle. Okay? So rectangular pyramid. This is a rectangular prism. Now, I want everyone on their paper right now, down here, I want you to sketch a triangular pyramid and a triangular prism. Okay? Sketch a triangular pyramid and a triangular prism, please. Bless you. Okay, ladies and gentlemen, here we go. I'm actually using your book here, but rectangular pyramid, notice, triangular pyramid. Now, Emily asked a good question. This is like a circular pyramid. Well, a circular pyramid we actually call a cone. Okay, but yeah, a circle base. And tell your neighbor what this is. No. Okay, Carson, what is this? What is this one? Yeah, pentagonal prism or pyramid. Now, note that's different than this one down here. This is a prism. A prism, this triangular prism, notice the difference between a triangular prism and a triangular pyramid. Pyramid comes to an apex, a point at the top, whereas a prism has two triangles, two bases that are congruent, connected by a bunch of rectangles. Okay, they're bounded by rectangles. This is a triangular prism. This is a triangular pyramid. This is a pentagonal prism. This is a pentagonal pyramid. Note the difference. Okay? I know, and it's a cool word, pentagonal. Yeah? Two pyramids whose bases are stuck together. Yeah, they're special, like the bottom of the page. Okay, everyone take a look at the bottom of the page. All right. So Grace's question is, what do we call this? Well, these polyhedrons have special names, and we're not going to go into a lot of these. Some of them are on the back wall back there. Up there it says polyhedra. This is actually called an octahedron. Okay, an octahedron. I know. So tell whether the solid's a polyhedron. Yes, it is. It's called an octahedron. Now, I don't need you to memorize that name, but it's an octahedron. Is this a polyhedron, though? Oh, it looks good. It looks like, put some sprinkles on it. But the answer is no. Does not have edges and faces. Oh.
It could be a bagel.
Bagels are good.
All right. Getting distracted. Page 333.
At least at a hotel and they do complimentary.
Test to answer questions 1 through 6. 7 and 8 will challenge you. Work with your groupies. I'm going to hand out today's stuff. Okay, ladies and gentlemen, let's take a look at this. Sounds like there's some confusion. May I have your attention up here, please? Describe the cross-section formed by the intersection of the plane. So in other words, this darker shaded area, what is this shape?
Rectangle. Square.
That is, depending upon if the pyramid's a square. So assuming it's a square, then this would be a square. Otherwise, it would be a rectangle. Okay? So that shape form, I'm going to say rectangle because I have no way of knowing that that's an actual square there. Okay? So where this plane, it's like a knife cutting through that pyramid, where that plane intersects that pyramid, what do you get? You get a two-dimensional shape of a triangle. All right? Tell your neighbor what you think on number 5. What shape do you get when that knife's through there? Okay, so right here we get a What do you think, Haley? That is a trapezoid. Trapezoid. How about right here? How many sides? 7. It's called a... It'd be nice if I could trace that last side there, yeah. Heptagon.
Hepta?
Heptagon.
Wow.
Heptagon.
If I had to memorize all of these names, that would take so long.
Yeah, man.
Decagon.
Okay, any questions on
The
those?
only one I know. Oh, and the hexagon.
Yeah, Emily. Quiet, please. Yes. Okay. Number 7. Logan, read the directions for us, please.
In exercises 7 and 8, sketch the solid produced by repeating figures around given axis and identify the inscribed solid.
So we're doing the same thing that we were doing with this thing, right? We're pretending like you have a pencil and you're rotating this shape around the pencil. Well, in this case, this isn't the shape, right? Yeah, I know. I want you to write down or draw a picture of what you think this three-dimensional solid is going to look like when you rotate it around this axis. Okay? Give it a go and try the same thing for 8.
Yes, KBC.
That's an idea. All right, well, let's see.
If you want it identical.
So I have that. That's that side. And I rotate it around. Now, when I rotate it around, this is going to be kind of like so. Now I'm going to end up erasing part of that. And it's three-dimensional. So there's this circle at each end here. So this part right here that I have, the solid line, that's kind of a circular piece. Oops.
Oh, well. Never mind.
So rather than this being 2 centimeters, it's now 4 centimeters. So put the measurements there. And rather than this being 4 centimeters back here, it is now 8. So 8 centimeters. And this whole length from end to end is still 8. That is my figure.
Well, I guess.
How many had it?
Plastic on that.
How many had kind of it? How many messed up on the ends? It happens a little on this. So double check number 8 right now. This one's kind of weird. See, a good strategy is to just duplicate it like this first. So you kind of get an idea of what it looks like. Helps when I'm... Sorry. Okay. So now that's not the actual shape of it, right? But it kind of gives you an idea. The bottom's going to be what? It's going to be curved. Okay. So you end up with a top that kind of looks like maybe like a tent of a circus tent or something. Okay. You have the sides. So the only part that really changes from what we have is the bottom. The bottom is circular. Okay, because we're rotating it around in a circle. Kind of looks like so there. The middle, from top to bottom, has a height of 4 centimeters. The base has a length of 16. Now this is I really messed up on that side there. So I'll fix that up. 16 centimeters. All right, and this height right here is 2 still. How many got that one? Dude, that's the big top, man. All right. Yeah. Why don't I come over and you can describe it. Okay, I want you really quick to take a look at your assignment. Passed out. Your assignment is 1 through 11. 1 through 11.
We didn't get it.
I know, I don't give it to you guys because some of you over there don't pay attention to my instruction after I hand them out. So I gave them to everyone except you guys. But I'll give them to you guys here in a minute. 1 through 11 on your assignment. Okay? Here we go. So just A. So you can cross out the side B. I wasn't sure what I'd give you, but it'll definitely be side A. Cross out side B. You could try number 12 for extra credit. Okay? But I definitely want 1 through 11 done.
Do the teachers make these